firstly, everyone, let's take a look at the second question. Have you seen this question already? Give me a big thumbs up if you got it. Okay, so everyone, let's read the question together. Mrs. Tan bought 3 muffins and a loaf of bread. One bread, 3 muffins, right? And then if Mrs. Tan only have 50-cent coins, how many 50-cent coins did she need to pay? Okay, so everyone, let's see. As for 3 muffins and a loaf of bread, that will cost how much? Firstly, let's see. 1 muffin costs $1, right? So 3 muffins will be 3 groups of $1. Give us how much? Type in your chat box. That will be $3. Okay, good job. Then see, how about the bread? The bread cost $4, so 1 loaf of bread will just be 1 times $4. Give us how much? That will be $4. Good job, everyone. So this time, if we want to see how much does Mrs. Tan need to pay, then we just add them up, right? So that will be 3 plus 4 give us $7. Okay, easy peasy. Teacher Jane got the answer. That will be B. So I put B here. Am I correct? A lot of you chose B just now. I saw according to the data, a lot of us chose B. Am I correct? Good job, Evelyn. Good job, Maggie. Okay, actually, no, everyone. You can see, because this means we need to pay $7, but Mrs. Tan only has 50-cent coins, right? So you can see this time, how many 50-cent coins did she need to pay? So we can see $1 equals 100 cents. So if $1, that will be how many 50-cent coins? Yes, $1 will be 2 50-cent coins. So $7, that means we need how many 50-cent coins? Yeah, that will be 2 times 7 give us 14. Okay, so actually the correct answer here should be E. Okay, understand? Give me a big thumbs up. Yes, good job, everyone. So proud of you. Then this time, let's move on. Here, we're gonna see the fourth question. Turn to the next page. For this question, all of you did quite well. So for the third question, we just skip this. A piece of square paper, a square-shaped paper, according to the steps shown below. How will the paper look like after we cut a small triangle and unfold it? Okay, so everyone, every time when we got a lot of steps, like this, and then fold like this, and then fold like this, then we just go backwards step by step, right? So you can see, firstly, after we fold like this, we unfold it, right? So you can see, if we unfold it, the paper will look like this, right? Okay, there will be a diamond shape here. Then everyone, you can see, oh, sorry, I erased this. Okay, then you can see after we unfold it again, how this will look like. Yeah, you can imagine this one is still like here. And then there's another diamond. Okay, and then we unfold it again. That will be like this, right? So every time you just work backwards by 1 step and then see how it will look like. Then it will be fine. So type in your chat box which one is the correct answer. Good job, Evelyn. Good job, everyone. Okay, so we can see the answer here should be D. Congratulations. Then let's move on. Here, the fifth question is about the age. We're gonna compare Maddie and Lola's age and Ellie's age, okay? So we can see here, Maddie is 2 years older than Lola. Okay, so for the comparison question, we can always draw a magic arrow, right? Draw a straight line, an arrow, and then this is younger, Everyone, you can also draw together with teacher Jane, okay? Take out a paper. And this is older. So let's see step by step. So firstly, we can see Maddie is 2 years older than Lola. Okay, so we know Maddie is older than Lola. So if this is Lola, where should be Maddie? Left or right? Here or here? Okay, where is Maddie? Yeah, this part should be Maddie, right? Okay, so we can see it's 2 years older. So we can label this part is 2 years older. And we also know that Lola is 6 years younger than Ellie. Okay, so we can see Ellie should be older. So Ellie should be on the left side or right side of Lola. Okay, right side, right? Okay, so we can see here, it should be this one, right? So this one is Ellie. Then we can see the difference between them is 6 years old. So Ellie is even older than Maddie, right? Okay, so this time, Ellie is how many years what than Maddie? Okay, so you can see if we know like this part is 2 and the whole part is 6, like this is 6, this part is 2, then how about this part? Type in your chat box. Type in your chat box. Yeah, that will be 4, right? Okay, so we can see Ellie should be 4 years older than Maddie. Okay, so the answer is C. Yeah, Maddie, the name is quite, seems like Maggie, right? I see your in your chat box. Okay, then everyone, so we can see this question, we need to choose C. Then this time, let's move on. Okay.
Find all the cubes.
Okay, so because next question will be about the cubes, let's take a look. How many cubes can you figure out in this picture? Type in your chat box. How many cubes are there? Okay, you see 1, 2, 3, 4, 5. 5, right? Okay, good job. Then we can see this time we're gonna talk about the sixth question. It is about the nets of the cube. So we already know cube got 6 faces, and net means like you can imagine the cube is made of paper. After you unfold it, how it will look like. So you can see here. Okay, you see this is a cube, right? Actually, on the cube, there are many knowledge points. So here we can review together. You can see here is the purple part is called as the face. The face. Sometimes it could be curved, sometimes it could be flat. And on the cube, there are 6 faces. Okay, actually, this is a cuboid. Okay, this seems more like a cube, right? You see, 1, 2, 3, 4, 5. 1 face on the top, 4 faces on the body, 1 face at the bottom. So there are 6 faces in total. And then as for the age is just the, you can see sometimes we say the age of the screen, the age of the desk, right? Age is just a line. Okay, then we can see 1, 2, 3, 4. 4 ages on the top. 1, 2, 3, 4. 4 edges on the body. 1, 2, 3, 4. 4 edges at the bottom. So actually on a cube, there are 12 edges. And then we can also see vertex. Vertex. Here are the lines, the edges that meet at the point. We say this is vertex. The cube got 8 vertex. Okay, so as for the net, it's just like we can imagine that if the cube is made of a paper, after we unfold it, how it will look like. So everyone, you will notice that here, there must be 6 small squares on the net, right? This will help us a lot. Okay, but someone may ask, oh, Teacher Jane, is this the only possible net of the cube? Actually, no. Let's take a look. Actually, we can see there are some 4 types of net of cubes. The first one is called as 1-for-1 type. You can just imagine the one on the top, we unfold it, and then the 4 here. These 4 are just the faces on the body, right? 1, 2, 3, 4. And then this one at the bottom is just like this face at the bottom, right? Okay, so actually for the 1-for-1 type, sometimes the 1, they could be at different places. Okay, be careful, the head and the tail. This little head and this little tail are always opposite sides for the top and the bottom of the cube, okay? Okay, so every time if you see 1-for-1 type, this will help you a lot. Okay, remember this. You can also write down the note on your book, on your paper, okay? This is called as 1-for-1 type. Then we're gonna move on. Here we also get 2-3-1 type. Okay, then someone may ask, oh, Teacher Dean, how does this look like? Actually, as for this one, these 3 kids, these 3 squares are also for the body, and this one is also for the head, this one for the tail, but this one, how about this one? This is actually after you fold it, it will also be on the part of the body. Okay, so after today's class, I will also send you a paper that is about the different types, and then you can print it out and then cut it, then fold it by yourself. Okay, you can try all the different kinds. Okay, so the second one is called 2-3-1 type, and then the next one is called as 2-2-2 type. Okay, 2-2-2 type. It looks like a staircase. And then after we fold it, it can also become a cube. And then this one is 3-3 type. Okay, so these are all the 4 types. So if you can remember, you can also type in your chat box. Everyone, type in your chat box. The first one is called as 1-for-1 type. And then we learn about the 2-3-1 type. And then we also learn about the 2-2-2 type, also the 3-3 type, right? Okay, so here are the 4 types. Okay, so everyone, this time we can come back to the question. Come back to the 6th question. This time the question will be super easy, okay? So which one cannot form a cube? The first one you see, this is it the same as what we learned just now? No, not the same, right? Actually, this is 3-3, but you can see, is it the same as this lightning shape? This 3-3? No, you see, this one, only 1 square are connected to each other, right? Okay, then you can see actually A is wrong. And then we can also move on to the B. B is what type? Can you type it in our chat box? Yes, good job, Evelyn. Okay, B is 2-2-2 type, right? And then how about C? What type is it? Type in your chat box. Yeah, C is 1-for-1 type, right? And then how about the D? Yeah, it's also 1-for-1, right? So we can see only A is wrong. Okay, so this is how we solve the problem. I give you 30 more seconds to remember all the 4 types, then we will move on, everyone. Okay, then everyone, this time let's move on. Here, for this question, how many bricks are missing? This is question 9. Everyone, let's turn to the page of question 9. Here, how many bricks are missing? Okay, so we can take a look. How many bricks are missing? Okay, so we can observe that as for each layer, the bricks, we can firstly draw the layers, right? Because this won't change. Oh, it's not that strict. Let me use the ruler. Okay. Everyone, you can also draw together with Teacher Jane, okay? Okay, let's see. And then we can see for each layer, there is a pattern. That is, you see, this one is that from one brick. Is that from one brick? Is that from one brick? So as for the border of each brick, they are also the same. They align with each other, right? Then let's move on. How about this layer? How should we figure it out? How many bricks are there? Yeah, it just goes align with this one, right? And then let's move on to the next one. Okay, every brick, they got the same size. So this will be quite easy, right? Then let's move on. As for the next layer, it's just like this, right? Okay, so you can see we got another several bricks. Okay, erase the one that we don't need. And then you can see as for the next layer, it just looks like this. Okay, then everyone, let's move on. And you can see here, this layer, it just starts from half of a brick, right? So this time, it will go with this line. Okay, so let's move on. 2, 3, 4. So 5 more bricks. Then this time, let's count. How many bricks are missing here? Okay, so this time we count. As for this layer, there are 2 missing. For this one, 1, 2, 3, 4, 5. 5 are missing. And then for this one, 1, 2, 3, 4, 5. 5 are missing. So in total, there are 12 missing. Okay, so everyone, this is how we solve the problem. Then everyone, this time, let's move on. Aha, naughty teacher Jane is coming. Then you can see. Okay. Let's see. Teacher Jane set fire to the wall and then make a big hole on it. Okay, so everyone, let's take a look. Here, if Teacher Jane give you 3 shapes to help you fix the wall, then which 2 can you use it? This one is not on the paper. This one is just a little bit level up. Let's take a look at this question together, okay? Okay, so as for this question, we can see how to fix the missing bricks. So you can see this one, we call it as the big C method. Everyone prepare your pencil. We're gonna take some notes together. Okay, so the first C is for connect. We connect the lines. And then the second step is to count. The second C, right? Everyone write down count on your paper. Then the third C is compare. You can see we can compare starting from the special pieces, right? You see this one is the same as this brick, this part. And then the second one, yeah, it should be here. Okay, then the third one, can or cannot? Cannot, right? Okay, so we can see after do the compare, we can figure out the first one and the second one should be correct. Okay, good job. Good job, everyone. We can see if we got this kind of question, we just start to compare from the unit parts and the big C method. Let's repeat together. What are the 3 big C's? The first big C, connect. The second big C, count. And then the third big C, compare, right? Okay, connect, count, and then compare. These are the 3 ways. Then, everyone, this time let's move on to the 10th question. Okay, so everyone, we can see this one. Let's read the question together. Okay, let's see. A cut was made along the dotted line. How many pieces will the string be cut into? Okay, so everyone, let's take a look at this question. Actually, we already discussed about this like last week, right? You still remember the Think Academy's Secret Garden? That is about the relationship of intervals and the parts, right? You see, this is still the same question, but still a lot of you got it wrong. So be careful, everyone. Let's see. A cut was made along the dotted lines. How many pieces will the string be cut into? Okay, so as for this kind of question, we just always count the cutting points because this will be related to the number of pieces, right? Everyone, let's see. If Teacher Jane got a string, if I make 1 cut, then how many pieces? Tell me in the chat box. 2, right? If I make 2 cuts, how many pieces? 3. 3 cuts, 4 pieces, 4 cuts, 5 pieces, 5 cuts, 6 pieces. So you can see the number of cut points is always how many pieces minus 1, right? Okay, so everyone, here is the relationship. So every time when we want to see how many pieces, we don't have to count one by one, but we just count how many cut points are there. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 cut points will result in how many pieces? 12 pieces, right? So the answer here should be E. Who can understand? Give me a big thumbs up. Okay, then everyone, this time let's move on. Here we can also review what we learned last week, right? This is about Think Academy Secret Garden. Teacher Jane grows carrots in a row if I put a stone between every 2 carrots. Every 2 carrots, I put a stone. Then, if I put 6 stones, how many carrots are there in total? Yeah, the stones are just like the intervals, just like the cut points, right? So there will be 1 more carrots. There will be 7 carrots in total. Then, let's see. Teacher Jiyoung put a light between 2 wooden planks. So between 2 wooden planks, there is a light. Okay, so now there are 6 planks. There are 6 pieces, just like the strings, right? 6 parts. So there will be 6 minus 1, give us 5 lights, right? The lights are just like the intervals. Then Teacher Mingjie cut the string along the dotted line. This is still the same, right? You see, 1, 2, 3, 4. 4 cut points will result in how many pieces? Yes, 5 pieces, right? Okay, so everyone, this is how we solve the problem. Then, everyone, this time, let's move on to the 11th question. Okay, so firstly, you can read the question, and then we're gonna take a look at this one together. Okay, so everyone, we can see which figure can we form with 3 L-shaped figures. So if we want to make 3 L-shaped figures just like this, that means we will have how many cubes in total? 3 times 3 give us 9, right? So firstly, if you want to try, you can also see which one don't have 9 bricks. That can help us a lot. But we can also try it one by one. So as for the first one, we can observe like this, and then another one in between, another one on the right side, right? So this figure, we can do it. So you can see which option don't have the first one, then you can cross it. We can cross option E. This can never be the correct answer, right? Then let's have a look. How about this one? The second one, which one it should be? Okay, how it will be? Okay, it's like this, right? And then we can see this one, just like this, right? And then as for the third one, let's take a look how we solve the problem. Okay, so for this one, it's just like this. And then this one behind, one on the top, right? So the third one also can. So as for the 1, 2, 3, all of them can. Okay, then you can see the first one. The first one, how about this one? Can or cannot? Okay, we can try it, right? Okay, so you see, if this one in the middle, can we have another L shape? Seems cannot. Okay, so as for the first one, this one cannot. We cross it. And as for the fifth one, we can also double check this one like this. As for this part, then you can see here, this one is so long, we can never get it, right? Okay, so as for the fifth one, also cannot. And after double check, we can make sure option A is the correct answer. And then we can also check the last one, this one, can or cannot? Cannot, right? Because we don't have the line shape. Then this time, everyone, let's do some quick quiz together. Before we move on to the next question, let's see how can we count the squares. Firstly, let's see how many squares are there. Just two, right? Then let's move on. How many squares? 3. Okay, this one, how many squares? 4. Okay, good job. This one, how many? 5? My answer is correct. Is it correct? Okay, actually it should be 6, right? Because the 4 small squares will become another one. So when we are counting about this kind of question, we need to firstly count small single squares. There are 5. And then as for the bigger one, 4 small squares will become another one. So there will be 6 in total. So every time when we count the squares, we just count in order from the smallest to the biggest. So everyone, this time, let's turn to the page of the 13th question. As shown in the figure below, there is a total of how many squares? Just now we say we can count starting from the small squares, right? The small single squares. So you can see how many are there in total. 1, 2, 3, 4, 5, 6, 7, right? 7 small single squares. And then we can also count to bigger ones. If we want to see like the medium size, this is small size, this is medium size square. Okay, like this. Then we will get how many? Let's count. 1, 2, 3, 4. Anyone else? Yes, one more in the middle, right? 5. Okay, so we can see for the medium size, we got 5. And then everyone, let's move on. How about the big size? Do we have bigger size? Yes, we got another one on the top, right? So you can see here, there is another big one. Okay, so everyone, we can calculate. In total, we get how many? 7 plus 5 plus 1 equals 13. So the answer here should be D. Good job, everyone. This time, let's move on. The 15th question. This question, 81% of us got it correct. Okay, so everyone, this time let's take a look. Glenn is older than Florence. Okay, seems like this time we're gonna compare. So can you think of when we are comparing a lot of items, what can we use? We also use it just now. The magic arrow, right? So you can see this time we are comparing who is younger, who is older. So we can label like this. On the left side, it is younger. On the right side, it is older. So as for Glenn, it is older than Florence. So this is Glenn, then older than Florence. So Florence should be on the left side, right? Okay, this finished, then we tick to remind us. Then Ahmed is older than Zara but younger than Florence. Okay, so we can see Ahmed is older than Zara but younger than Florence. Okay, so this one should be Ahmed, right? It is younger than Florence but older than Zara. So where is Zara? Even on the left side, right? So here is Zara. So after we finish the second clue, we tick it. Then the third clue, Oliver. Oliver is younger than Glenn. Oliver is younger than Glenn. What do we know? Is it here, here, or here? Seems don't know yet. And then let's move on. Younger than Glenn, but older than Zara. Okay, so Oliver may be here, right? But do we know is it like older than Florence or not? Seems don't know. So we leave this clue here. And then everyone, let's see. Yasmin is younger than Glenn. Yasmin is younger than Glenn. And do we know where is it? Seems still don't know, right? Okay, so we leave the clue here. So everyone, we can see. If every time we got the clues, but we still not sure yet, we can skip it first. Okay, so this time let's see. Ahmed is older than Oliver. Ahmed is older than Oliver. So this time we can know, right? Just now we said Oliver is younger than Glenn, but older than Zara between here. And this time we also know Ahmed is older than Oliver. So this is Oliver, right? Okay, everyone. So we can see sometimes if the clue is still not sure yet, you just leave it here. And after we finish, we tick it. Then let's move on. Florence. Florence is younger than Yasmin. Florence is younger than Yasmin. And we also know Yasmin is younger than Glenn, right? So this one should be Yasmin. Then this is how we solve the problem. We can see which of the 6 friends is the youngest. Type in your chat box. Which one is the youngest? Okay, good job. That should be Zara, right? Okay, so the answer is B. Perfect. Okay, then everyone, this time let's move on. Here, question 18. Let's turn to the page. Question 18. Have you got this? Yeah, let's see. Sharon went to the park. Sharon went to the park. She took 30 minutes to reach the park. And then blah, 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 blah. A lot of items have happened, right? So this time we can draw a timeline. Okay, let me use the ruler, draw a timeline. Okay. So you see, she went to the park. This is the start. This is the beginning. Then you see, she took 30 minutes to reach the park. This is 30 minutes. Okay. 30 minutes. Everyone, draw together with Teacher Jane, okay? And then you see she reached the park here. And then she ran for 2 hours. Oh, so energetic. She ran for 2 hours in the park. Okay, so we can see another 2 hours. Okay, then she finished running. When she finished running, it was 7:30 p.m. This is 7:30 p.m. What time did she go to the park? So our task is just to see what is the time for the start, right? Okay, so this time let's go back. So let's see. Just now we say 2 hours. She runs 2 hours, right? Then let's see. How about this one? Oh, sorry, this is not part. Okay, so we can see 2 hours earlier. We just minus 2 hours, right? So you see, before 2 hours, what time is it? That should be 5:30 p.m., right? So you can see when she reached the park, it was 5:30 p.m. And then we can see this time we also need to go back another 30 minutes to see when did she go to the park. Okay, so we can see here that will be minus another 30 minutes. So it is 5 p.m. Okay? Okay, 5 p.m. Good job, everyone. Oh, Maggie says you run 20 rounds. Yeah, maybe 2 hours you can run 20 rounds. Okay, good job, everyone. So we can see here is how we solve the problem. Okay, then this time let's move on to question 21. Question 21. Have you got a page? Question 21. Okay, so we can see Jason and Rachel are standing in a line which has a total of 11 people. So maybe this one is about queuing problem, right? So let's take a look. There are 7 people in front of Jason. And then if Jason is just in front of Rachel, how many people in the line are behind Rachel? Oh, this time so many information, so confusing. How should we do it? Let's see. When we are doing the queuing problem, we can always use the ways that we can draw it, the diagram. The first step, everyone, is to draw a flag. Take down the note, everyone. Write down together. Draw a flag to show where is the front, where is the back. The flag shows the front, okay? Then, let's see, the second step, draw the main character. Main character, the main person in the question. I just write down MC for main character, okay? Then the third step is to label the number. Okay, so everyone, let's see this time. We can see in total there are 11 persons. So we can draw a big bracket. There are 11 persons. And then we can see there are 7 people in front of Jason. This is Jason. We write down J and then draw a circle here. There are 7 people in front of Jason. So there are 7 people in front of Jason. And Jason is just in front of Rachel. So Rachel is just behind Jason, right? You see, this one should be Rachel. So this time, what we're gonna calculate is to see how many people in the line are behind Rachel. So how about this part? What is this? Then how can we write the equation to write it down? Okay, everyone write the equation on your book, on your paper. Okay, so this time we can see in total there are 11 persons, right? And then in front of Jason there are 7 persons. So teacher Jane feel like, oh, my answer is 4. Am I correct? No, because don't forget that Jason and Rachel are not counted. So we need to minus another 2. Then we will see there are 2 people behind Rachel. So this is how we get the answer. Okay, everyone. Then this time, let's move on to question 22. Question 22. Okay, a sailor tied 7 knots on a rope at regular intervals. Okay, so actually this is about the interval problem again, right? If you got it wrong next week, I will be so sad because we already see the question, same type of question a lot of times, right? You see, a sailor ties 7 knots on a rope at regular intervals. So let me draw a big rope first. Yeah, this is the rope, and then we got 7 knots. 1, 2, 3, 4, 5, 6, 7. 7 knots. The distance from the first knot to the 7th knot is 18 meters. So this is the first knot. This is the 7th knot. Is 18 meters. So what is the distance between every two knots? So you can see 7 knots give us how many intervals? How many small intervals? Let's count together. 1, 2, 3, 4, 5, 6. 6, right? So what we're gonna do is just to do 18 divided by 6 give us 3. So we can see the distance between every two knots should be 3 meters. Okay, so if you until now you still cannot remember the times table, then you need to be careful because a lot of questions will be about the times and the division. Okay? Then everyone, this time let's move on. 23rd question. The bar graph shows two types of keychain that Kuma collect from different countries. Given that Kuma collect twice as many keychains from Malaysia as from China, how many keychains did he collect altogether? Let's see this question. Okay, so everyone, let's see how can we read this kind of chart. Yeah, you see, this is bar graph, right? And then we can see the bar graph, every bar, the length, the head of it, just show the number of keychains, right, from each country. So for example, as for this one, this means from Australia, there are 350 keychains. And then as for this one, this means in China, the keychain, there are 200 keychains from China. Okay, so you can see, given that Kuma collected twice as many keychains from Malaysia as from China. So from Malaysia, we got how many? Twice as many as China. So 2 times 200 will be 400, right? Okay, so we can see, as for Malaysia, if we want to draw the bar graph, it will look like this. How many keychains did he collect altogether? I saw a lot of you got the answer as 400. Is it correct? No, everyone be careful. We need to see all together, not just Malaysia, right? So let's do the plus together. For Australia, we got how many? Type in your chat box. 350. From China, we got how many? Type in your chat box. 200. And from Malaysia, we got 400. And from Japan, that will be 300. So in total, we got how many? After calculation, we will get an answer that will be 1,250. Okay, so this is the answer here. Okay, everyone, this time, let's move on. Question 24. Okay, this question, only 16% of you got it correct. So as for this one, we can talk about it for a long time. Actually, for the next paper, we also have similar questions. You can also try it again. Okay, so everyone, let's see. At a supermarket, every 3 empty bottles can be exchanged for a new bottle of drink. What does it mean? Let's see. Every 3 empty bottles can be exchanged for a new bottle of drink. Just like this. Can you understand? Give me a big thumbs up. And then you can see Rachel has 29 empty bottles. Then we can see 29 bottles. Empty bottles, we can get how many full bottles? Yeah, this one will be related to remainder, right? Let's see. 29 divided by 3 give us how many whole groups? 7 whole groups, right? Because we know 3 times, that will be 9 whole groups, right? Because you can see 3 times 9 give us 27. And then we still have 2 empty bottles that cannot redeem, right? So you see we got a remainder of 2, these 2. You see, we got 9 complete complete bottles, and then 2 empty bottles. Okay, so everyone, some of you just write down your answer should be 9. You can got at most 9 bottles. Actually cannot. This is because Teacher Jane is so thirsty. So I drank all the 9 bottles. So this time, everyone, you see, as for the 9 bottles, just now we say the 9 bottles, we can also redeem, right? Every 3 bottles can redeem another one. So this time, you see, the 9 bottles, every 3, we can redeem another one. Every 3, we can redeem another one. So you see, 9 divided by 3 give us another 3, right? Okay, so around this time we can see we already got 9 plus 3. Is it all? Actually, we can still have, because you see, these 3, after we finish all of them, we can also redeem another empty bottle. We can also redeem another full bottle, right? And then this bottle can be combined with these 2. So we can redeem another one. So we need to plus another one. So in total, there will be a lot of bottles. Okay, so this time let's come back and then see how many we can get in total. Okay, so everyone, let's take a look. Let me clear all of them. Firstly, let's see. Just now we say 29 water bottles. We can divide it by 3. That give us 9 complete bottles with a remainder of 2. And then after we drink the 9 bottles, we can exchange 3 more, right? After we drink the 9 bottles, we can get 3 more. So get 3 more. And then the next step, after we get these 3 more, we can exchange another one. After we drink all of them, another one. And then after we exchange another one, we can also combine with these 2 empty bottles. Here, this one. It can be combined with this one, right? So we can see in total, there will be 9 plus 3 plus 1 plus 1. That will be 14 bottles. Where are they from? This is the 9 in the beginning, and we get 3 more, and then we exchange another one. Then after we finish, we can also combine with these 2 to redeem another one. So in total, that will be 14. Okay, so this is how we solve the problem. A little bit tricky, but as for today's week, or after today's class, I will also give you a sample paper. There are similar questions, okay? Then this time, let's move on to the last question for today. Let's read the question. As for this one, also only 19% of us got it correct. So let's take a look. Eddie formed a 4-digit number, 2014, with several matchsticks. Please add 5 more. Add 5 more matchsticks to form a 4-digit number. Be careful, everyone. Add 5 more means that we need to put more, right? Can we move the position of different matchsticks? No. Can we just take away some? Cannot. We can only add some more, right? Okay, so let's see. What is the biggest possible number? So every time when we talk about get the biggest number, that means the biggest digit should be the biggest, right? So let's see. What are the digits here? This is 1's digit. You can also label on your paper, okay? This is 10's digit. This is 100's digit. This is 1000's digit, right? Okay, so we can see this time, if we want a number to be the biggest, we need to make sure which digit is the biggest. Type in your chat box. Yeah, that will be the thousandth digit should be the biggest, right? So you see, this time that will be, how about 9? Can we form a 9? Seems cannot, but we can form an 8, right? So Teacher Jane just used 2 matchsticks. Remember, we got 5 in total. I used 2, so right now I only got 3 left. Let's see. We still have 3 left. And then we want the number to be the biggest, so which number we need to be care about the next? Yeah, the hundredth place, right? So the hundredth place, can we make it become a 9? Cannot, right? But we can make it become an 8. Okay, so you see, we add another one here. Then this hundredth place will be 8. Okay, so right now we still have how many more sticks? 2. 2 more. Okay, then as for the 10th place, what is the biggest number? Can we form a 7? And then we still have another 1 stick. And a lot of you just got, oh, Teacher Jane, then I put 79. Am I correct? Actually, this is no, because you see, digital 9, we also need another one at the bottom. So we don't have enough matchstick. You can 1, 2, 3, 4, 5, 6. This time we will need 6 matchsticks. So cannot, right? So actually, what we're gonna do is just to think about, is there another way? Yeah, that is, we can form a 4 here. Put another 2 matchsticks here. Then it will become 8,844. Okay, so this is the biggest possible answer.